Today we are speaking about measuring tip or empty device for relative and absolute dosimetry in brachytherapy, where precision of position in ionization chamber is even more significant than in teletherapy. Here I will talk about brachytherapy water phantom, where main ideas are implemented. In difference from teletherapy water phantom, where we used water surface as a mirror to reflect the empty device, in the brachytherapy phantom, the mirror for reflection of empty device is a lower surface of plastic plate. All distances are counted from this surface. It plays the role of zero coordinate. As an initial phantom was taken the CNMC phantom. Our base plate was mounted into its position assembly. The plate should be horizontal with tolerance level plus minus 0.1 degree. The empty device enables to perform positioning of ionization chamber from base plate with accuracy plus minus 0.1 mm. From the radiation source side, we should reduce positioning uncertainty too. The mold probe used for transportation of the source has outer diameter 1.8 mm and wall thickness 0.15 mm. The source capsule diameter is 0.9 mm itself, and its uncertainty inside the plastic tube we estimate as plus minus 0.25 mm. If we create a turn of mold probe, we make an effect of pressing down the active part of the source cable to lower wall of the probe, reducing by this way the uncertainty of the source positioning down to 0.1 mm. The mold probe is tightly fixed to base plate. So finally, as a result of all these technical tricks, we estimate the uncertainty for source to ionization chamber distance as plus minus 0.2 mm. For clinically used distances, approximately 4 cm, as acceptable because it corresponds uncertainty plus minus 1% in dose rate. The position of the radiation source is geometrical center of the water tank. Crosshairs drawn on the wall of the water tank enable more precisely to find this position for mold probe. The ionization chamber used for absolute measurements should be certified for iridium beam quality. In our case, pharma chamber calibrated to cobalt and orthovoltage X-rays, and energy correction factor for iridium was calculated by interpolating this data. The final result for dose rate in this source to chamber distance for nominal 10 Curie radioactivity source is 0.51 gray per minute. And what is the source to chamber distance? To calculate it, we should sum up empty device constant, distance from the base planes to upper surface of ionization chamber. Then next summand is radius of the ionization chamber. Next step, we should take into account displacement of the ionization chamber center due to quite large longitudinal dimension of the chamber. If center of the chamber placed at 4 cm distance, the tip of the chamber will be at 4.12 mm distance from the source. It means for the distances around 4 cm, this correction factor delta is 0.6 mm. Iridium source transports to calibration position, which we estimate as 1 mm from base plane. So we sum up all these items and subtract 1 mm. The result, final for distance, is 38.4 mm. The brachyvision treatment planning system gives us the dose rate from the 10 Curie iridium source at the distance 38.4 mm, 0.52 gray per minute. Comparison of measured and theoretical values for dose rate for around 4 cm distance give us difference 2%, which is in tolerance level of 3%. Here you see some conclusions. The main is the brachytherapy absolute and relative dosimetry can be done directly in water with acceptable accuracy, similarly as we do it in teletherapy. Thank you for that attention.